All right, good afternoon. We'll get started now. So thank you for attending the College of Humanities and Sciences open house today, and particularly for coming to this talk on the Data Science Analytics program at NUS. So with me this afternoon, I'm happy to have them to help me this afternoon to answer questions are Associate Professor Carol Hargreaves, who is the Director of our Data Analytics Consulting Center, Dr. David Chew, who is the Assistant Head of my department,
Hi, everyone.
and Dr. Vic Gopal, who is leading various things, including a recent revamp of our Data Science and Practice module. So I am Associate Professor Lim Tiong Wee. I will be sharing with you some aspects of the Data Science Analytics program in the next half an hour or so, and then we'll then start answering your questions, either through the Q&A, or if the questions are asked a lot, then we will pick some of the questions to answer live as well. Okay, so let's begin. All right. In case you didn't get your questions answered, or you think of more questions after this session, please feel free to email musliha@nus.edu.sg. Musliha is our program manager. All right, so she will then collate your questions, and we'll try to answer these questions to the best of our ability. Okay, so the program is Data Science and Analytics, and at the center of it, of course, is data. So some anecdotal data trends would be that the human race is producing a lot of data. Some studies place it at 2.5 exabytes of data every day, and that's a lot of data, 2.5 times 10 to the power 18 bytes. As an estimate, the human race has created until now some 40 zettabytes of data, and we are creating more data and at increasing speeds, particularly also because there are smart devices that are connected across the world, and these devices are collecting data, analyzing them, and then sharing data with each other as well. So that's something called the Internet of Things, and it's enabling new applications, including such things as smart traffic management, environmental monitoring, predictive maintenance, logistic and fleet management. And data is consumed in many different applications, including such things as high-frequency trading, risk management, recommender systems. Any of us who has been watching streaming, either on Netflix, Disney Plus, or you name it, or done online shopping, would be familiar with recommender systems. You have watched this, you may want to watch these other programs. You have purchased this, people who have purchased this also purchase these other items. You may want to take a look at them. So that's the recommended system working in the back end. Consumer intelligence, personalized medicine, genome-wide association studies, and of course, central to Singapore, the Smart Nation Initiative, which is consuming a lot of data to better our lives. All right, so we'll just briefly talk about a definition, or at least our working definition of data science. It is interdisciplinary. It's about processes and systems to extract knowledge or insights from data in various forms. Data science makes use of techniques and theories drawn from three domains: computer science, mathematics, and statistics. And this, in some sense, guides us in our design of the curriculum, which I'll talk about shortly. So what do data scientists do? They apply analytical tools and techniques to both structured and unstructured data to solve complex problems and derive actionable insights. So this program is about getting you ready to be a data scientist. So it's about equipping you with tools and techniques, and it's about giving you opportunities to learn how to solve complex problems and how to recommend actionable insights. So we have been featuring these three alumni for quite a few years already, but since every year is a different audience, it's befitting that we do it again, basically. So we have Dr. Eric Sandosham, who graduated from NUS in 1995 with a bachelor's degree in mathematics. He has then gone on to work for a CD Group And then much more recently, he has his own consulting firm right now. So what does he do, or how does he describe what he does? He provides data-driven solutions for clients across Asia Pacific in diverse industries. And what we really want to emphasize here in his quote is the fact that he mentions diverse industries. So a graduate from data science really is not constrained to work in any specific industry. Many industries are collecting data and in some sense overwhelmed by data, and what they need would be expertise, people with expertise who are able to analyze and interpret what's in the data and then recommend actions that can bring profits, that can bring efficiency and whatnot. So he blends the arts and science of analytics to connect the dots between people, products, and profits. And we have Ivan John Clement, who graduated in 2013 from computational biology. This predates data science and analytics. So again, he's gone on to several job roles, and his most recent job role is in Switzerland with Roche as an R&D portfolio data strategy lead. So he utilizes advanced analytics and machine learning to analyze healthcare data sets, which transform our understanding of healthcare outcomes. This enables us to deliver the right drugs to patients at the right price. So in some sense, you can see that Ivan is actually, saying something a bit more specific than from what Eric has been saying. He is in the pharmaceutical industry, and what he is doing is to actually come up with ways in which they're able to deliver the right drugs to patients at the right price. So you can see where the people are, where the products are, and where the profits are. And we also have Pei Yuxuan, who graduated from statistics in 2014. Again, this is before the DSA program was introduced. And again, he has gone on to many different job roles. This quote was when he was with the Lazada Group as a data scientist. He has since, I think, moved through 4 other jobs. Currently, he's a software engineer for machine learning at Meta, and I believe he works out of London currently. So when he was with Lazada Group, what he used to do was to develop machine learning models that analyze large-scale data for consumer behavioral patterns to make personalized product recommendations. So if you had purchased things from Lazada back then, and you saw good product recommendations, it's probably part of Yuxuan's job to make sure that recommendations are good and relevant. Okay, so some details about this program, the Data Science and Analytics Undergraduate Program. It's a degree program leading to the Bachelor of Science degree with honors. The major is Data Science and Analytics. It's jointly offered by 2 departments in the Faculty of Science, my department, Statistics and Data Science, and the Math department. And this is in collaboration with the School of Computing. Students in the DSA program have the option to specialize in operations research and statistical methodology. Okay, some further details about specialization will be mentioned later. So what is the program objective? The program aims to equip you with analytical tools and techniques to solve complex data scientific problems in various sectors and domains, as well as skills to communicate insights gained using visualization tools. So this ties back to what was mentioned earlier in terms of what a data scientist does. Okay, we were the first university in 2016 to offer such a degree program in data science and analytics. We have since had 2 cohorts graduate from this program, and they have enjoyed a competitive edge in the job market. Okay, I haven't included the data here, but you can take a look at the graduate employment survey for last year and the year before, and you will be able to find that graduates from the data science and analytics program have done well in terms of both employment, proportion employed in full-time jobs, as well as median starting salary. So how did we design the curriculum when we started our program in 2016? We designed this program such that it has basically two key components: sufficient technical depth. Okay, this is important because technical depth is what ensures that our graduates are able to develop novel tools for various applications and problems that will emerge in the future. Okay, so technical depth is essentially the thing that will future-proof our graduates so that when new problems come along, they can go back to the drawing board and design new solutions to these problems. And the program also includes a breadth of domain-specific knowledge. Okay, and as part of our strategy to do so, we have various sense-making case analysis modules, which I'll talk about later on, and it allows students to actually apply their technical skills to many different domains, okay, and see how their technical tools are able to improve things in these domains. Okay, we have several industry-linked modules and projects within the curriculum. This is important so that not only do our students learn from professors, they also learn from the practitioners, okay, and are able to catch up with what are the state-of-the-art approaches in the industry. Okay, so hard skills are those parts of the knowledge and skills that are picked up from coursework from within the university, from working with the professors. Soft skills are those that students pick up through projects, through internships, and also through our sense-making case analysis modules. Okay, so those are skills in problem solving, storytelling, collaboration, curiosity, communication, and creativity. Okay, on our part over here, the professors, of course, will impart in you data and technical skills, math, and statistics knowledge. Okay, which brings us to the program structure, which again I will talk about briefly. The program, the data science analytics programs, are offered under the College of Humanities and Sciences. Okay, so it belongs to the Humanities and Sciences course. Okay, at the end of this talk, I will have a slide that tells you how to apply to NUS to read data science and analytics. Okay, the way is to apply through the Humanities and Sciences course. Okay, it is a bachelor's program, an undergraduate program leading to a bachelor's degree with honors. So in NUS language, this means it is a program that requires at least 160 modular credits. Okay, most modules in NUS are 4 modular credits. So 160 modular credits is equivalent to 40 modules, completion of 40 modules typically. Okay, there are 3 big components, major components to the program. There are requirements for the College of Humanities and Sciences Common Curriculum. There's, of course, the requirements from within the major, the data science and analytics major, and the remaining 3 electives will be what we call unrestricted elective modules. So roughly 1/3, 1/3, 1/3, roughly. Okay, those of you who have gone to the talk this morning, where the vice deans of undergraduate education explain the common curriculum would have already seen what are the various components in the common curriculum. There's AI, artificial intelligence, C&E, communities and engagement, data literacy, digital literacy, design thinking and writing, as well as Asian studies, humanities, social sciences, scientific inquiry 1, scientific inquiry 2, and then there are 2 interdisciplinary modules as well. Okay, so students in the DSA major program would fulfill the data literacy requirements as part of the major, okay, by reading the gateway module. So, so in some sense, you get a freebie, all right, from the major. And so the 52 MCs of common curriculum effectively becomes 48 MCs. The major requirements take up 60 MCs, of which 52 MCs are essential modules, 8 MCs are electives. Okay, some of you who may have studied the curriculum previously before CHS came about, and you would have found that the curriculum used to be 96 MCs. Then you might ask, what has happened to the other, 36 MCs or so? The reason is that when CHS came along, the curriculum has been redesigned, okay, in such a way that the major requirements are really absolutely what you must have. Okay, but if you want, and we encourage everybody to think very carefully about this, if you want to be able to practice as a data scientist, then you are going to have to go deeper than what the major requirements provide you with. And that's where the specializations come in. All right, so that portion of the curriculum is now moved into what we call specializations within the major. So data science and analytics provides two specializations. One is statistical methodology offered by my department, statistics and data science. And then the other is in operations research offered by the mathematics department. Each specialization requires 20 modular credits or equivalent of 5 modules. You can do none of those, which we do not encourage. You can do one or you can do both. So that's how it's different. The CHS career is different than the old curriculum. Okay, essentially, if you complete the specializations, you will have exactly the same amount of depth as you would have achieved under the old curriculum. You could also use your unrestricted electives to participate in internships, which we highly recommend. Read a minor or two, or read a second major. Okay, internships in the Faculty of Science would give you 12 modular credits within a semester, or 4 modular credits during the summer break. Minors are 20 modular credits per piece. Second majors are 40 modular credits. Okay, so of the remaining 52 modular credits to make up the 160, these are the various things you can do to fill up that space. Okay, I cannot emphasize this more. The 160 MCs, okay, comprising these components is the absolute minimum students need to complete to graduate. Okay, minimum. Okay, students may exceed 160, all right? And it's important to emphasize this because very often when we talk to students, they seem to think that the 160 is a golden number. They must be, they must hit 160. They're very wary about going above 160 by too much. And if one is ambitious and able to do so, we encourage students who are ambitious and who have the aptitude to actually think about how to fill this space. And if they do more than 160, it's fine. All right. So very quickly, what's in the major requirements? The 52 plus 8. There are foundations from computer science, mathematics, and statistics. There's also skills and knowledge from data analytics, including such things as visualization, computation, and optimization, and techniques such as regression analysis and machine learning. Okay, this is the absolute minimum already. And, I again want to emphasize that we strongly encourage students in the DSA program to read one or both specializations to get that depth that will prepare you much better for the industry. Okay, besides some classroom taught modules, there's also ample opportunity for experiential learning. The DSA program is one of the few in NUS that has the Cooperative Education option, okay, which I'll talk about very shortly. Students are encouraged to participate in internships. The Data Analytics Consulting Center brings in projects which we have had students work on in the past. If you join us this August or later, okay, I'm quite certain that overseas student exchange will return to full swing by the time you get to year 3, okay? And we have a suite of data science case analysis, sense-making case analysis modules that allow students to work on hackathon problems in the classroom setting, which is again something I will talk about very shortly. So what's cooperative education? I usually would call this internship on steroids, because not only does a student go out on one internship or ad hoc internships, this is one where we design and incorporates 12 months of internship within the curriculum, okay, so that students don't spend more than 4 years to complete both their studies and these internships. Okay, so cooperative education allows students to combine academic studies with on-the-job learning. Okay, we have agreements with several of studying employers, okay, who actually provide opportunities for our students to go on such extended internships. And because the curriculum has changed since the CHS came about, the sequence in which the internships come in are under review right now and pending approval. So students who opt to participate in cooperative education may begin their 12-month internship in semester 2 of their year 3, okay? And that will last until December semester 1, so it's December of their year 4. So that's the 1 calendar year. Students who opt to begin their co-op internship in May, that's a special term of 1 academic year, would then continue on their co-op internship until the following May, early May, when they typically complete their studies. Okay, so this is currently under review and pending approval, but we don't expect surprises. So that's cooperative education. These are some of the co-op partners. You can see that they are from various industries and sectors. And we have had students gone out on various types of internships, okay? And these are some of the internship partners. So these are the non-co-op internship partners, okay, that have offered internship positions to our students, current and past. We have a consulting center, and what it does is it provides students in the DSA program with opportunities to assist in its consulting services. This allows students to hone their programming, statistical, and communication skills. And it also provides students with the opportunity to gain practical experience in formulating data-driven solutions for real-world business problems. We have sense-making case analysis modules. Amongst we have since then, I think, run this module has made 7 runs, okay, and we have 6 pairs of sectors. So in one of the earlier runs, we had a collaboration with RISE-X, DNVGL, to provide students with hackathon projects related to the maritime industry. And in one of these projects, students create computer models that analyze 10 billion lines of AIS data. And this is to determine whether illegal fuel bunkering can be detected using vessel pattern analysis. So what the AIS does is it's a system that tracks the location of vessels, shipping vessels, and the activities, okay? And by analyzing that data, the intention or the objective is to see if the vessels or some of the vessels could be doing funny things, such as taking fuel from illegal sources. So that was one of the projects we have seen, and then we have had projects where we collaborated with hospitals to look at the operational side of things, okay, and also with colleagues from A-Star to bring in problems in genomics. We've also had other runs that look at natural language processing, looking at annual reports which companies file with stock exchanges, to see how well they're doing in environmental sustainability. We have also had projects that deal with a furniture retailer, online retailer, okay, to analyze website traffic and see how they can optimize the design of the websites to drive sales. In the previous semester, we have had a collaboration with GovTech where students looked at computer vision data to do various things. So there are many very interesting hackathons that we have run for this particular series of modules. What are the career prospects? We expect our graduates to have good career prospects across many different industries, both public and private, in many different sectors. Okay, just to show you show you where these are actual employers of our graduates. So we have had 2 cohorts gone out, so they graduated. The first cohort was only 30 students. The second cohort who graduated just this last June, we had 60 of them. Okay, and on this slide, you see 24 employers. These are actual employers. Of course, there are other employers that I couldn't squeeze into this slide over here, but and it's not to impress on you how good these employers are, but to impress on you that there are employers in essentially every sector that are actually hiring graduates into data science / data related roles. We've actually had students gone out and become software engineers, okay? And the curriculum allows you to do so. Remember that you have ample space in the curriculum, okay? The unrestricted elective space allows students to learn many different other things, okay? You just have to look around for opportunities for minors and second majors within the university, and then you'll be able to learn those things as part of a minor or a second major. Okay, so I mean, not to advertise these employers or to favor some over others, but I just want to highlight interesting, perhaps interesting in a sense that non-conventional. You wouldn't think that these employers actually hire data scientists, but Charles and Keith actually had, I have hired one of our students. She did an internship, and then she was hired. She does merchandising analytics. Okay, so retailers need expertise in analytics too. Mandai Global, our zoo, basically, has also hired one of our students. So these are maybe, you know, employers that you don't expect or you don't think of typically, but they are hiring our graduates as well. So I would say that the career prospects are very healthy for our graduates. All right, this is perhaps the most important slide. Apply to us, okay? This is how you do so. To read data science and analytics as a major in NUS, you will have to look for the humanities and sciences course. Okay, you need to apply to the humanities and sciences course. You do not declare your major when you apply. Okay, the data science and analytics major is part of the humanities and sciences course. When you apply, there is no need to declare your major. Okay, you declare your major only after you have accepted our offer. If you're successful and you join us in August, okay, that's when you declare your major at matriculation and then register for modules. Okay, so this is important, humanities and sciences course. The major, however, has a subject prerequisites. The data science and analytics major requires a very good H2 pass in mathematics. Okay, without an H2 pass in mathematics, a student will not be able to declare it as a major. Okay, they will have to read the bridging module MA 1301 Introductory Mathematics to bridge up to the H2 level in mathematics. Okay, the integrative grade profile has been released for the intake last August. this is the integrative, indicative, okay, wrong word, grade profile. 10 percentile A, B, B, B. That's 3H2 and 1H1. Okay, so that's for your reference. The actual cutoff this year may be higher, may be lower. All right, so if you're interested in doing data science and analytics, please do apply to us. Humanities and Sciences course. Okay, and this is where you go to make the application. All right, so I think we'll take questions now. Okay. I will just, I mean, there are some answers that questions have already been answered by my colleagues. So I will maybe now run down the list and try to answer the rest of the questions. I mean, we just talked about how to apply, and there's a very good question here. If I were to get into humanities and sciences, will I be able to choose data science analytics without restriction? So the quick answer is no restrictions. All you have to do is to fulfill the course prerequisites, the subject prerequisites. Very good H2 pass in mathematics. Okay, assuming you got into the humanities and sciences course, okay, you can declare the data science analytics major with no restriction. So at the two extremes, if nobody who got into the HNS course declares data science and analytics as their major, we close shop. If everybody declares it as the major, we have to take all, provided you have the prerequisites. So no further restrictions in that sense. Okay. So that's already answered live. Okay. I believe Professor Hargreaves wanted to answer a question live. To what extent, what is the extent of difficulty of math and coding in DSA? Perhaps Carol, you want to say something about that?
Yeah, so basically I wanted to say that before time, definitely you don't have to have the knowledge in your programming. So the extent to which the difficulty level is actually quite manageable, because we actually handhold you when teaching the coding, and we ensure that your coding skills, basically you also work in groups when solving problems. And so there's a lot of peer learning as well in the data science and analytics program. And so you need not fear, if you don't have programming skills, you need not fear that that will put you at a disadvantage.
Yes, thank you, Carol. Yes, to add on to that, the elementary modules that you take in mathematics as well as in coding, they have already taken into account what are the prerequisites. So the first two math modules that DSA majors take would have an H2 math prerequisites. Okay, so that's part and parcel why the subject prerequisite is H2 math. The first coding course, which is CS 1010S programming methodology, which is taught by our colleagues in the School of Computing, that has, I believe, a math prerequisite as well. So it's already been taken into account that with H2 math prerequisites, you should be able to cope. Of course, you have to work hard, okay, but you'll be able to cope. All right. So let's see. There's a question about majoring in data science and analytics and then taking a second major, and what might be good second majors to take, so to speak. Okay, a popular one is computer science to be observed. This is historical, all right, but you shouldn't be constrained by that. It depends on your interest. What is it that you want to do later on? Pairing DSA with, say, psychology may be sensible if you're interested in going into marketing, behavioral studies, for example. You can pair that with economics if you want to, pair that with computer science, pair that with management, which is what the second major for business administration is called. is really your interest and your aptitude. Okay, career prospects of DSA versus the School of Computing's Business Analytics. There are slight differences in the rationale behind the design of the curriculum. Okay, what we see is that DSA has slightly more technical depth, and because there is only this much curriculum space, this means that DSA students may actually have slightly fewer or less exposure to applications. Okay, but as I've mentioned earlier, technical depth is important because it allows our graduates to reinvent. New problems come about. We don't know what new problems there will be in the future, and that's the technical depth enables our students, our graduates, to be able to, come back stronger and go back to first principles and propose new solutions. So I think that's the strength of our graduates. In terms of career prospects, my sense is that for the first job, whether a person graduates from DSA or from business analytics, by and large, you'll be competing for very similar jobs. Okay, so it's important, whichever program you end up in, to work very hard and do well. Okay, so that's, I think, a very common question. Computational biology is an entirely different primary major. Okay, so it's not directly related to DSA, but there is a bioinformatics minor that DSA students can read. So that might be something of interest if this is asked by Rachel. If Rachel wants to major in DSA, one thing to think about may be to think about minoring in bioinformatics. Okay, a similar question. If an applicant successfully gets accepted into the humanities and sciences course, okay, and matriculates with us in August or another August, if you have to go through NS, then subject to having a very good pass in mathematics, declaring the DSA major is guaranteed. Okay, there are no further quota set aside for DSA. Okay, maybe I'll pause at a moment and maybe invite Dr. Gopal to say a little bit about the data science and practice module that he is currently teaching and leading a sort of minor reform in, so that it aligns and prepares the students better for the industry.
Hi, thanks, Tiong. So hi, everyone. Welcome to the session. So in the third year, there is this class called Data Science in Practice. So like over the past few years, we've been monitoring and watching what the industry is expecting of our students. So when they go out for internships, we follow them, we see reports on them. In their final year internships, we see what they did well, and what the companies are expecting of them. So we've been kind of following, and we're updating this Data Science in Practice class. So we're trying to insert as many elements as we see that the employers are asking of them. So we're keeping the program current, revamping and trying to cover technologies that they use in the companies, the ways in which they use them. And one thing we've seen that a lot of our students are being expected to do is not just run the algorithms and the machine learning, but they need to talk to the people who are eventually going to use the algorithms. In computer science and software, we call them users. It's the only industry, right? User. But they're actually the people who